Okay. So what we do is that we work on the detection so that we detect all this junk and protect the people, and we also research, do analysis of some of the more interesting stuff. And whenever something really interesting comes up, every once in a while, I present it at a conference like this. So as you probably have guessed by now, we'll be looking at the Induc virus. And whenever a real virus pops up, it's always quite interesting for us. That's a real file-infecting parasitic virus, not a Trojan. It also adds more work for us because we have to clean it. We have to restore the infected files to their original state. We can't just delete it like a Trojan. But it's always fun. It reminds us of the old days of the old file infectors. And not only is this topic interesting because it's a virus, a parasitic virus, but Induc itself is also a very interesting virus. It's not the traditional kind like a file appender or prepender, where we search the hard drive looking for executables to infect. But I've heard it called somewhere a compile a virus. So what it would do is that it would target developers' computers, people who are using Delphi, and it would infect a standard Delphi library in the programming environment. And as a result, every project, every executable compiled by this environment would get up infected. This has led over the past 3 years to quite massive spreading, because also legitimate companies who got infected by this and were shipping their programs, their applications infected. So the widespread. So this thing was quite widespread. So we'll be taking a look at more of sort of a high level look at the evolution, what the virus was doing in the early variants until from the early variants up to the most recent ones, and also a little more in-depth look at the code. So for all of the reverse engineers, or for all of the people who aren't working with malware analysis, don't worry. This is not going to be any hardcore stuff. We're not going to be looking at kernel mode rootkits and stuff like that. For all the reverse engineers here, I'm sorry, but it's not going to be any hardcore stuff. So it's going to be like a little analysis of a lightweight analysis of an interesting virus. Okay, so let's take a look at the first variant. As I mentioned, it's about 3 years old. At this stage, it was more of a proof of concept code, like an alpha stage. Somebody was apparently experimenting. It is also not the first compile a virus, like proof of concepts of this kind. They were also introduced back in the 80s for the C++ compiler, I think. So, but this is the first, I think, massively spreading example that at least we have seen. So let's take a look at how it proceeded with the infection. So it targeted a system library called sysconst.pass, some constant used by Delphi linked with every compiled project. It was targeting Delphi versions 4 to 7, and that's all it was doing. So it was spreading. It was infecting Delphi programming environments, but apart from that spreading mechanism, it had no real malicious payload. So let's take a look at the code, what it actually looks like. I hope the fonts are big enough for you to see. Okay, so there's that. That's the compiled one. That's the source code. Up here is the legit stuff, all the constants used by Delphi, and down here is the stuff that's not legit. By adding a few new lines, we could bring it to more readable form. All this code does, as I said, it infects the environment. So when this was run, all it was do is it would look up this file and add this code to where it's at right now. And this is where you can see where it's doing. So we'd look for the Delphi installation directory by querying the registry. It was starting versions 4 to 7. It only looked in this directory. Then over here, after having infected it, that's procedure RE here. So it would add all of that code in there, and in the end, it would run that create process with these parameters. So it would compile the pass file, and the resulting DCU would be linked to every project coming out of this infected IDE. Okay, back to the slides. Good. Okay. Then about 2 years later, the second variant popped up. The code has been completely rewritten. It featured some improvements, but it still had no malicious payload. So some of those improvements featured a better way of searching for the Delphi installation directory. Now, as you all probably aware of, Delphi has undergone some name changes from Borland to CodeGear. It was Borland Development Studio. I think it's Embarcadero now. So this targeted these name changes as well. It also made the code analysis a little bit more difficult by adding some encryption, using some really primitive anti-debugging tricks, and there were also some functions which I'll show you just now, but that are unused. So obviously somebody was experimenting with this stuff. Okay, so here again, syscons.pass legitimate stuff. At the bottom over here is something that's not supposed to be there, encrypted this time. And if we decrypt it, this is what we're ending up seeing. So from the strings, you can see that it's looking for the installation directory at different places. It's targeting different versions as well. The end result, what it would do is the same as before. But we also see some interesting strings like HAL DLL, URL mon DLL, stuff like that, which is unused. So that's ntdetect.com. And where's the anti-debugging stuff? Yeah, over here. So here are some really trivial anti-debugging tricks that it was using. That's pretty much it. So a little more time consuming to analyze. Still the same payload, i.e. no payload. It would just infect and spread. This version wasn't as successful in spreading as the first one, but that didn't really matter because a new version came later. Okay, and that's Induc C. So that first popped up in August 2011. Again, the code was completely rewritten, and this was a more major release. There were much bigger differences this time. The target library that it was infecting changed, so it was sysinit.pass now instead of sysconst.pass. It also added a classic exe file infection vector, so it would look for executables by traversing the file structure of hard drive, what a regular virus would do. And now it actually also did something evil. So let's take a look at this latest reincarnation of the virus. That's the sysinit.pass with just 2 lines of code inserted into the file. As you can guess, the function create my file from this array is defined in this defines.inc include. So let's take a look at that over here. Okay. Resolution change, sorry for that. Good. Okay, so the sysinit pass file looks like this. Let's see if I can find the malicious stuff really quickly over here. So there's this line of code was inserted by the virus, and this line of code was inserted by the virus. And as you can probably guess from just looking at that, here this array contains the body of the virus. It's 52,736 bytes long. And down here, we can see the part where it drops that onto the hard drive and executes it. So now it's regular compiled PE executable. So we'll be loading that up into IDA. So there's some installation stuff to remain persistent on the infected machine. That's not really important. I mentioned that it also has a secondary infection vector, so that it looks for executables that it would want to infect, and that's carried out in this function over here. Insert drives to infect, and this is the part where it actually infects the Delphi environment. So what I just showed you over there. Here, get logical drive strings, enumerates the drives. It filters for some drive types that it's not interested in, for example, CD-ROMs and stuff like that. Okay, this second part is used for the Delphi infection. So it would also check whether the system volume information directory is present on that drive. So this is an interesting method of checking whether it's a hard drive, not a removable media, for example. And if we go in here, you can see the typical stuff: find first file, find next file, traversal of the directory structure, and over here. Now the left path is taken for the Delphi infection. The right path is taken for the executable infection. So what it does is that it first checks whether it's in the correct directory. It looks whether this is present in the path, whether this and also this, and if it matches all these criteria, it decides that, okay, I found the correct directory. Let's run those 2 lines of code into that library, sysinit.pass, these 2 lines of code, and where is it? Over here, it would compile that. So it's really pretty simple technique. Okay, so I mentioned the secondary infection vector. So basically, it's a prepender type of virus, or more specifically, it would append the executable that is trying to infect in an encrypted form after itself. It would delimit that with string supernatural. That would also be a marker that the file was infected. And this is an example of one such infected executable. Down here is the encrypted original file. The encryption method, something really trivial, some XOR and add, nothing too fancy. Okay, let's look at the code one more time. Okay, so that's that checks whether the supernatural string is present. The strings are encrypted. Okay, nothing too interesting in this part. Of course, over here at one point it checks whether it contains an infected executable after that string, and it would execute that, drop it on the hard drive and execute that. So like a normal virus, there's no entry point redirection and all this stuff going on. So it's a really simple technique. So this parser search drives to infect that was infecting the Delphi in this case, and in this case, it was in this thread, it was searching for the executables. But one interesting thing to mention here is that this time it doesn't want system volume information to be present. So this secondary infection vector is used to facilitate it to spread even better. It's used for spreading via removal of media. So it doesn't infect all executables on the hard drives, but USB sticks, shared network drives, and stuff like that. And as I mentioned, it also has malicious payload. Like most, like over 90% of malware out there, it has some botnet capability, the ability to download other malicious junk onto the infected machine. So once they have accomplished to infect the machine, they want to leverage and make most out of that. So providing this service and basically downloading other malware and doing other malicious deeds over there. And here's a really trivial self-defense mechanism. You'll see in a later slide why I'm showing you this. It's really trivial. What it does is that it looks whether Task Manager is running, and when it finds it, so that's regular APIs, create tool hub 32 snapshot, process 32 first, next, etc. etc. And when it finds it, it simply exits. So the virus will terminate. But more on that later. And the actual payload, as I said, it's a downloader that would, okay, contains 3 URLs that it's trying to download from. We won't be able to see them here because nope. Yeah, because again, they're encrypted using this XOR and add. As you can see, it's an HTTP address. But the first file that it would download is not the file that it would also execute, but it does it in a quite interesting way. Okay, and the way it does it is that it downloads user avatars from certain discussion forums and hides more links in these. So the little steganography used there. Again, this is not the first malware to use this technique, but it's, I think, interesting nonetheless. So one example of such downloaded file is this. Okay, what's that? Unsupported video mode. Wonderful. So let's look at it like this. So here in the EXIF information, this part over here is another encrypted URL, and that's the one where it will actually download an executable from and execute it. So this is an interesting technique to control the individual bots. Provides a mechanism to update itself, but just by uploading a different avatar with a different link, the virus would download something different. And yeah, so it's an avatar looking like this. There's another one. There's three that. Those are the three download links found over there. Yeah, there's another URL. So what was it doing? What was it downloading? It was downloading piece of malware that we detect as that pswdelf.nqs. As the name suggests, it's a password stealer. So it's probably some kind of spying was going on, some kind of data theft. This also was harvesting FTP passwords and other interesting stuff. And so once we found, okay, this is an interesting piece of malware. It actually has a malicious payload now. Let's take a look at how successful the authors of this malware were, what they were after, what their potential targets could have been, and what was the scale of these attacks. So when we looked at our telemetry from the detection, we found something really, really interesting. Most targets in Slovakia, lots of targets in Russia. These two together form like almost 80% of all the worldwide detection. Now this Induc C variant, it wasn't spreading as massively as Induc A. So while Induc A we were detecting over the time like thousands to tens of thousands of detections per day when it was most active. This Induc C variant, it only infected a couple hundred computers throughout its lifetime altogether. And when we looked at the targets, it was no coincidence that these countries were so high in the statistics, because in Slovakia, one big manufacturing company was targeted by this data stealing virus, which I won't name for obvious reasons. And in Russia, it was two big targets, lots of other smaller ones, but two big and really infected ones. It was one really big Russian bank, and it was also an office of a Russian state institution somewhere in Yekaterinburg. So quite interesting. So we have this curious virus, which has an unconventional spreading mechanism used for data theft. So that's pretty much it for the virus family. So far up to date, we have not seen an Induc D, but it's not the end of the story quite yet. So who has heard of Dorifel or Quervar here in the audience? Yep, one. So you might have seen reports like this in the news. So this was quite big in the Netherlands, and lots of information has been released on this, publicized. Um, it was also malware used for data theft. It had different payloads. It was quite interesting. But what struck me as I analyzed Induc C last year, so when this came to light, is the amount of similarities to the code of Induc C. So this Dorifel, it was most active in, or it saw the light of day sometime in May this year. It was most prevalent in the Netherlands. It's not another incarnation of Delphi. It doesn't have that unique mechanism of it's not Induc. It doesn't infect Delphi like Induc does. Instead, it infects executables like Induc C. It's actually in the very same way, and it also infects documents, Word documents, Excel documents. It turns those into executables. It uses a really interesting technique for masquerading these infected files by using this right to left override trick. So when the file name of the infected file would be, for example, infected SLX SCR, so it would be an executable screensaver. But this Unicode character over there is the right to left override, which would uh, have the effect of flipping that to right to left. So on a default Windows 7 setup, this is what the victim would see. Now this doesn't work by default on Windows XP, because these right to left fonts, characters, whatever, they're not installed by default. But if they were, it would work as well. It's not the first malware to use this trick, but it's an interesting technique. And let's take a look at the similarities between Induc and Quervar that I was mentioning. So does this look familiar at all? Delimiter string, a different one this time, but the same way of infecting executables. It would add the encrypted executable after the body of the virus. The virus is written in Delphi again, like Induc C. The encryption this time is different. I have a table later on showing the comparison. It's not just XOR and add, but this is, I think, used RC4. Does this ring a bell? Just like Induc C was using the avatars on the forums, exactly the same way Quervar was doing that. So hiding other stuff to download, the links for them inside these avatars. And that seemingly meaningless and trivial self-defense mechanism is again used in Quervar. I don't know if you can see it from over there because the fonts are quite small, but it's, apart from the sleep value, it's exactly the same code. So here's a brief comparison of the stuff. As I said, both written in Delphi. They are both virus, so they're not Trojans. They infect stuff a little bit differently. Quervar also has document infection. Induc, on the other hand, has the infection of the Delphi environment. But then we see a lot of the code is shared, and it's very, very similar. Also, the traversal of the file structure, the recursive enumeration of the disks, the code over there is exactly the same. So yeah, that's basically it. We have seen a very untypical type of virus, which throughout seeing its evolution was first just sort of an experiment. Didn't do anything much. In the latest version, it was possibly used in targeted attacks. And then another malware family which shares a lot of code with Induc. Uh, Probably, as I said, probably not the same guys behind it, but definitely lots of inspiration from this family. So, if there are any questions, fire away. Okay, thank you.